Today's lesson is about solving compound inequalities with "and" in them. Basically, a compound inequality is two inequalities that are considered together. So, for instance, if we had y is greater than or equal to 5 and y is less than 12, that is a compound inequality. And compound inequalities can be written that way, or they can also be written in a little bit different way, where we write the intersection of those two. So it says here that a compound inequality containing "and" is the intersection of the graphs of the two inequalities. The solution must be a solution of both inequalities. So if we think about that, if we were to quickly sketch a number line here, and we had 5, 6, 7, 8, 9, 10, I'm going to run out of room here, 11, and 12, okay? The place that would be the intersection of the two inequalities would be the place where both of them are true. So in other words, y is greater than or equal to 5 would look like a closed circle at 5 with everything shaded in that direction, okay? And then y is less than 12 would look like an open circle, okay, at 12 with everything shaded in the other direction. The intersection of that is the place where both of those things are true, where the shading overlaps. So sometimes this could be helpful if you're working on these to shade with two different colors, if you have two different colors, or if you're doing it, in Notability, just choose two different colors to do the shading in. And I probably should have done that on this one. So, basically what we're looking at is the solution set is going to be this part of the graph, because that's the place where both of these things are true. So let's just take a look at some examples, and maybe this will make a little bit more sense when we look at the examples. Okay, here's an example from the textbook. It says graph the solution set of x is less than 3 and x is greater than or equal to -2. So we could actually do 3 graphs for this if we wanted to. We could, first graph the part that's x is less than 3, so that's an open circle at 3, and then we shade everything there to the left of that with a bolded arrow at the end, okay? We could then also look at the graph of x is greater than or equal to 2, or excuse me, greater than or equal to -2, and that would be a closed circle at 2, because of this being greater than or equal to. If it has the line underneath it, that means it's a closed circle. Okay, and shaded everything then to the right with a bolded arrow at the end. Okay, our next step now will be to draw where both of these are true. Basically where these two graphs overlap. So if I were to write another one here, I would have -2 and 3, okay, and the place where they overlap would be between -2 and 3. So I would go ahead and put my closed circle at -2, I would have an open circle at 3, and then I would shade everything that is in between those. Okay, so my shading would be everything here in between -2 and 3, because that's the place on the graph where they're both true. That's the intersection, the place where the two graphs overlap. And if you were going to ask me, do we really need to draw all 3 graphs? Maybe you need to start out that way, but once you get used to doing these, you should kind of be able to go straight to the 3rd graph and just graph this one and not have to graph those other 2 after you kind of get the hang of it. So let's take a look at one more example. Okay, in this particular example, this is another one from the book. It says solve the inequality -5 is less than x minus 4, which is less than 2. So first thing that you want to do is go ahead and break this inequality up into two different pieces. This is the same thing as saying -5 is less than x minus 4, and x minus 4 is less than 2. Be careful when you do these that you don't break up the x and the -4. Some people, when they first start to do these, think that the x goes with the -5 and the -4 goes with the 2, and that's not the case. You don't want to think of it like that. Instead, you want to think of it as everything, -5 all the way to x minus 4 for your first one, and then everything from x minus 4 to the 2 for your second one. So make sure you don't break up this middle part. Don't break up the x minus 4. Keep that together when you work these. So now we're just going to work these two inequalities side by side, and we're going to add 4 to both sides. And you have a -1 is less than x, and add 4 to both sides, and you get x is less than 6. Okay, so now we have the solution. So now we want to go ahead and graph the solution. So let's make a number line, and let's think about what this means. It says x is greater than -1. So here's my -1 down here, and I know I'm going to have an open circle because of this symbol here at -1. I know I have to also show 6 on the number line, and it's going to be everything less than 6. So basically what we're talking about here is everything between -1 and 6 that needs to be shaded. So if I go ahead and shade all of it, I'm shading everything, oops, open circle here, everything between these two. Okay, and that's what my solution set would look like. This is the place where they're both true. Okay, if, like I said, if you need to do the individual graphs first until you get the hang of this, go right ahead. We could have done that. We could have first graphed x is greater than -1. Okay, and then we could have then graphed x is less than 6, and that would be everything there. And then we could have looked at where these two graphs overlap and go, okay, I see where they overlap. They overlap in this area right here. So this is what's shown on my solution graph. Okay? So basically that's what we're going to be doing for a while. We're doing and inequalities tonight. Tomorrow we'll take a look at or inequalities. And that's about it. So be prepared to ask some questions in class to make sure that we understand how to do this, and we'll go over it in class tomorrow.